Hey everyone, thanks for hanging in there late on a Friday afternoon. I try to make the next hour fun and worth. I'm a pretty easygoing guy, and so we'll try to have some fun with it. Take questions at the end. Happy to do that if there are any. And so I will move off our little driving screen, which I stole off of YouTube with credit there. So I am, if the thing, there we go. That's me. I'm actually unemployed today. But on Sunday, I'm flying up to Connecticut to start a new job on Monday with Lockheed Martin as their chief strategist of artificial intelligence programs. I was recently with Honeywell as their chief scientist of AI and ML. And I also, as mentioned, do the Atlanta Deep Learning Meetup. And if you listen to podcasts, I co-host the Practical AI podcast with Daniel Whitenack. And our approach is making artificial intelligence practical, productive, and accessible to everyone. So it's a very down-to-earth kind of approach. I kind of got back into AI after a number of years of being away. Started off with Accenture on their first AI team before going to Honeywell. But I actually first touched on this 26 years ago now. And it really happened with this. Does anybody recognize this? If you know anything about military jets, F-22 is still today the top air-to-air superiority combat fighter in the world, dogfighting, you might say. It's made right here in Marietta, just north of town at the Lockheed plant, although they've stopped manufacturing new ones. But this was built, and way back in the early 90s when they were first putting the program together and doing the initial prototypes, one of the first prototypes crash landed. Let's see if the video will work on this. There we go. And the pilot was fine, but the plane was supposed to have the avionics that kept crazy things from happening. And so the test pilot was pushing the stick back and forth, trying to hit the runway, and sadly the avionics let him, which was an error. And can you all hear me, by the way? Everything good? Okay. So this turned out to be a huge issue for the Air Force and Lockheed, and it was gone back to the avionics team, and this guy here was the engineer who was assigned to tackle the problem, and he spent a year working with neural networks on it, and that was my dad. So I would come home, I was a college student, I would come home and we would talk about neural networks after, that was part of our dinner for about a year. And that was kind of my intro into it. You raising your hand, sir? Sure, yeah, I can hear something back there as well. So I'm going to keep rolling forward while he turns the music off here. But then I went away, became a software engineer for a number of years, and then eventually got married, had a child and all, and kind of found my way back into the space. And I'm sorry, it's going backwards for some reason. There we go. There we go. So I'm here today to talk about artificial intelligence, specifically deep learning, in a particular context. Last year I was talking about kind of how to get into deep learning and some of the things that you need to think about. And this year I'm talking about how are organizations out there using this new tool to affect their business and change their business. And so I'm going to talk a lot about deep learning specifically, but it's in the context of digital transformation, which is how people are predominantly using it. It's really important that when you talk about digital transformation, marketing people tend to think of it, oh, it's digital, it's a channel. And that's not what we're talking about here. And transformation is not a project. Hey, let's get a budget and get a team, project manager on it, go do it. Digital transformation is probably poorly named because it's really a holistic strategic process that organizations have to go through. The fundamental purpose is not to take your existing operations and to digitize them. The fundamental purpose is saying, if we were to start a business over today, with all the cool tools that we have today and with everything that we're trying to do, and I'm sorry about that, I'm moving out of the box there, then what would we do? How would we build this from scratch? And so we now have this whole new set of tools that we can apply to the business operation. And so you're really talking about trying to reimagine entirely different business processes and focus on that. So it's really about inventing or innovation in your business as opposed to optimization of an existing state. And so the challenge here is that because we're going through all these technological revolutions that we're doing, the actual process of digital transformation itself is evolving and changing as we're using it running forward. And so it's a real challenge if you're a business leader and you're trying to take advantage of some of these tools, because the tools you're using are changing out from under you. So, if you look at what's happening right now, we're accelerating up this exponential curve. And it's really notable when you look at it historically. We started with the cognitive revolutions, which you might think of as what made humans special about 70,000 years ago, roughly. Moved on to the agricultural revolution of 12,000 years. Big change with both of those events in terms of what could be possible. So, you're really looking at something that is a technology that is affecting the very heart of what it means to be human and how humans conduct their affairs, including business. So it's changing the social, cultural, and economic aspects of what that is. And so you could think of that digital transformation is really at the heart of what's happening in business as it changes, and that the AI-driven processes that are deep learning and other tools to come are really at the heart of what that digital transformation is. So, we're already using it at this point to change how business models are being reimagined. And if you read the news and, even popular things like CNN, doesn't have to be technical news, you see organizations grappling with this every day at this point. So you could think of it this way, just to simplify and give you a little contextual framework. You could think of AI as the technology, and you could think of digital transformation as the strategic process that you're applying the technology to. You could maybe say AI is the noun, and digital transformation is the verb that you're operating with. So it's truly changing the fundamental process of what a strategic process at an organization is and what it can do going forward. And we're at the beginning of that process. That rate of change is actually increasing exponentially right now. So I've thrown around deep learning and artificial intelligence, and so I want to take a moment because you've been through a number of speakers here, and I've discovered something which I'll illustrate in a moment, but we probably need to talk about what do I mean when I say artificial intelligence. In other words, can I define what it is to me? And that is easier said than done. And you say, well, why? Well, because if you ask a bunch of different experts what AI is to them, you're going to discover that they all give different answers, including me. And so the reason I know this is the case is that a few months ago, this is exactly what Adobe did with a group of us. They asked me and 9 other AI experts to come to a broadcast on, it was a Facebook broadcast for 90 minutes, and go through kind of a forum environment. And this was that crew. I'm on the right. This is just the face shots of everyone involved. Some really amazing people in this group. And so I discovered that I needed to really address how do I define AI, because all 10 of those people had different definitions for it. For me, I define it very narrowly, more narrowly than anyone in that group. For me, AI is kind of a marketing buzzword, and so is, for that matter, really digital transformation. They're buzzwords. So I would say that really the power of AI flows from deep learning. This changes. If you think of AI as an evolving buzzword, when I was looking at it in the 90s with my dad, what AI was then was very different from what it is now. Neural networks were coming about, but there was another set of technologies that people were considering to be AI. And now we're in 2018, and we have kind of a different set of things that we're looking at and saying, this is AI. And I would bet you that in 2030, as we look at AI, we're going to also discover that that's a different set of tools. So right now, I would argue that it's deep learning and associated technologies like reinforcement learning and such. I realize that not everybody's going to agree with me, might get you in trouble with some people. That is me, by the way, on the picture. So I did notice coming out of that same group, though, that there was one thing that I wanted to talk about, especially in this context of digital transformation, that all 10 of us agreed on, and it surprised all of us. And that's the fact that no matter how you're using this technology that we're calling AI, the deep learning tool set that we're using now, it needs to start with what the customer is requiring us to do on their behalf. How are we creating value? And that's really the same with any technology. There's nothing AI specific about that. But if you're not starting with what that requirement is to satisfy the need of who you're attending to, the customer in this case, then you're probably going to go off track. And we'll delve into that a little bit. So deep learning is, it's really, as I said, the modern version of AI that's working today. This is a definition that will probably change over the next few years from my standpoint. You could think of it as the driver of the current AI revolution. And it really comes down to this inspiration of saying, if we model ourselves around the human brain, throw in a healthy dose of stats and applied mathematics, and we get this models, these neural networks that are changing, and there's tons of them now, tons of different architectures. This is incidentally a quote from the deep learning textbook, which is the textbook in the industry for learning that. I highly recommend it. And it's really, we got multiple exponentials which are driving the adoption of this. And one of it is we have tons of data and more data coming online all the time. We have essentially infinite compute power, if you're willing to pay for it, available in the cloud or buy your own supercomputer like we've had at work in the past. And the techniques are evolving really, really fast. And so when you put all these exponentials together, I mean, that's why this is happening so rapidly, and each one drives the other. So you could really, really think of it as the modern application of neural networks that is creating the field of deep learning. It is learning from data without explicit programming. And you could call this neural computing. And I want to address what that means for a moment. We're going through, let's set aside the AI buzzword for a second and talk about what the nature of computing itself is going through right now. We tend to think of ourselves as this is a data science thing, this AI thing, but really it's changing how computing itself is going to function. We've always done if-then statements and case statements and loops, and as programmers doing a job, whether that's our primary job or part of getting our primary job done, we've had to think of all the different things we had to address and cover. And bugs happen when you don't address every possible use case and every possible twist and turn that model you're creating is. So what we're changing now in this world going forward is it will become very common for us to have models at the center of our programming, at the center of our systems and software engineering. And so that changes how we think about solving problems fundamentally. So this is kind of, people say, how does all this fit together? And this is how I do it. Incidentally, it used to be that there was a common thing, and I used to use it too, where it kind of had AI as the big bubble, and the machine learning and that, maybe deep learning smaller, or some variation. I said, it's actually reversed, at least the way I see it. You kind of have the world of data science, computer science. As a subset of that, there's machine learning, and then as a subset of that, you have deep learning techniques. But there are certainly machine learning things that are not in deep learning, and there are certainly all sorts of things in data science that don't fall within machine learning. So this is a good way to think about the relationship. And so I kind of wanted to talk about how this is being done in industry, and that's really where I come from, is the industry perspective. Google led the way, as we all know, and it was a big change for them. They went for a decade telling us we're all about mobile first. And then a few years ago, they switched over and they said, now we're all about being AI first. And in doing that, they were not calling it that at the time, but what we're now calling digital transformation is what they were going through. And that is, they were looking at all of the things they did as an organization, and they were recasting them. How would we do this today? We have this great new set of tools. How are we going to apply those tools to make our services even better? And they went back through and looked at everything. That's not optimization. That's innovation. It was the same products, but they changed how they were delivering those products and what those products could do. And it was a big change, driven by what their customers needed. This guy here about 2.5 years ago made a prediction about this. And the prediction was, if you jumped into this 3 years ago from that point, then you would have wasted all sorts of money and effort and resources and stuff. But if you wait 3 more years, you're going to be hopelessly left behind. And I used to wonder, I believe the sentiment, I don't know about the timeline. And I've actually come to realize, as I've looked, especially over the last 18 months, I think he hit the timelines right on. Almost everybody is at least dabbling in AI or thinking about it. It's now part of the conversation at organizations. They're trying to figure out how to apply it. And so it's definitely something that we need to be focused on, and it's going to become commonplace because you're essentially going to have and I think I may have done it again. I keep whacking the audio. Okay. So this is being deployed in the form of microservices going forward because that is what software engineering is moving toward in general. And so I mentioned before with this neural computing, it's going to be common to have that at the center of your structure. So you're already consuming these microservices every time you open up Gmail or any one of a number of other services from many other companies. But if you're not already doing it, you're going to start delivering your products and services this way going forward. This is how the future works. So a bunch of use cases here. The short here, and this is just a tiny little smattering, is essentially security, marketing, different versions of computer vision, natural language, transportation, healthcare, financial. That list could go on and on for many slides if we wanted to. There's few industries that are not going to be. I just keep whacking this thing, so I'm going to tie my hand behind my back. Okay, I think we're going. So I'm going to stick this over here since it makes for great video, doesn't it? Okay, there we go. So maybe I won't whack it over there quite as much. So this is just a few things. Andrew Ngee, many of you are probably already aware of him. He is one of the founders of Coursera, put the first really big machine learning course online that many of us have been through. This was a slide just to make it simple on how some of the common use cases are that people tend not to think about are. And so people often say, well, what is AI good at and what's it not so good at? It's really good at solving complex problems that are very, very, very specific. So they can be hard problems, but what we're doing today is very narrow scoped. And so for a given neural network model, and you might have many models to solve more complex scopes, but initially that's where we're at today. It's very limited. So what's it bad at? It's really not so good if your problem set itself is continuously changing. The fundamentals of the problem are changing because then you're constantly having to retrain your model to track on where the problem has gone. So I'm not just talking about different variations, different values that are going into your model, but if the actual nature of the business problem is evolving, which it is for many businesses, that's really hard. Or if it requires a lot of creativity. Now, I will point out that there is a change to that. I don't know how many saw the article recently, but the first piece of high-value AI-created art sold recently at Christie's for $432,500. Just as a side note. So high-end art is now fully aware that AI is a real player in the space. So I may have to change that definition fairly soon. These are some of the things I wanted to draw out is that the way humans and AI are interacting, there's kind of several models. If you're looking at an autonomous vehicle, I get in, and I'm really talking about the ones over the next few years as opposed to what's out on the street right now. You're really delegating everything to that vehicle. There's a point not far down the road where you get in the vehicle and it does all the work, and you're just kind of cruising along, letting it do its thing. You have industrial robots, and there's a combination of you delegate certain activities to the robot, and you're collaborating with that robot quite a bit. And so it's a partnership in a sense. And then we obviously have consultation that happens through our current mobile devices and wearables that we're going to be using. So there's a lot of different places where these technologies are showing up. And this really is pretty amazing in that I know AI is scary to a lot of organizations and people on the jobs front, but what we're seeing in reality right now, the data that we're seeing is there are some jobs going away, but on the other hand, the people that are still there are gaining superpowers relative to what they used to be able to do. It's really increasing the per unit productivity in a big way. So let's talk about kind of what this is doing. We're all familiar with Google's cars and all the other organizations that have cars out there. And we're also seeing the fact that this is really driving the conversation at this point. I used to work, like I said, at Accenture, and we were constantly talking about bots for this. All the customers wanted bots. I have a niece who works for a competitor to Accenture, and we were at my mother's birthday dinner last night, and she was talking about, oh my gosh, did I do it over here now?
Let me give you that.
I don't think I bumped it that time. There we go. Sorry for this. It's still, while he's doing this, it's still not the biggest challenge I've had in a speaking thing. I do a fair amount of speaking, and as a sideline while he's doing this, I was going to Boston for LiveWorks, in case any of you have been there, doing a keynote, and I flew in it and got to my hotel at 11 p.m. in the summer, and I was only wearing sweats because it was a fly in, give it first thing in the morning, and fly back, and I realized I'd left my pants, my suit pants at home, and I had no other clothes. So yeah, it was a quick trip to Macy's in the morning before going, but that still qualifies as the biggest challenge for me during a keynote. They're going to edit that one out as well. I hope.
Not that part.
Not that part? Uh-oh, I'm in trouble. I need to stop talking. So this is really going more and more, and we're going to show an example of that. Gartner is now projecting that 50% of the population will focus on these bots that are on their phones over the next few years. So think of what you're doing right now. If you have any kind of medical issue, small or big, and how you're addressing that, this is changing not only the entire medical industry from how do we reinvent ourselves perspective, but it's also a gigantic opportunity for organizations that are going to support this. This is a huge case of digital transformation that we are just barely scratching the surface on. But within the next 5 years is going to be a massive, massive shift culturally for how we operate. So everyone's building chatbots. Cut everything else you're working on. We're going to go build bots to support everything. It's a funny there, but it's very true in terms of priorities. Obviously, you have really powerful tools like DeepMind that's addressing cancer. You have gun violence. You can place microphones around an urban area and have natural language processing address gunshot sounds and then feed it to other neural networks that resolves what they think that is and then notify the police in microseconds from when the event actually happens so you can route police faster. This lady here, very impressive, is the Chief Information Officer at the UN. And she has been talking a lot about this, and she's basically pointing out that this is going to change the whole world right here. We need to think of ourselves as transformation agents and innovators, and we need to rethink how we're addressing these, especially since it's affecting business so much. 20 years out is very different, she says. Nobody has any clue what 20 years looks like. We're not sure what 5 years really looks like if you think about it. And that's not something we would have said when I was a kid. Life was not changing at that rate of, the pace was not quite so fast. So we're getting to a point where the horizons of what is possible is being invented so quickly at this point that the ability to predict the future is coming in. So she points out that we're really looking at creating forms of artificial intelligence over the next few years that themselves are going to be innovating, just like that expensive picture that I was talking about that Christy sold, where the AI itself begins innovating on itself. And there's actually a lot of research being done right now in the AI world on how to do that. There's a lot of AI begetting AI work. So this is going to shift what everything from the labor force, and at least 80%, might be higher than that in some cases. How does labor work in this new world? And how does that affect the rest of your lives? So I hope I'm not scaring you too much, but you're entering a world of massive change coming up. And our children, I have a 6-year-old daughter that I showed at the beginning, we're all going to have to reassess even how we do parenting, how we do education and stuff. So digital transformation is, even maybe more than AI, is the buzzword for the foreseeable future about everything we do in life starting to move forward. China is getting this. China gets it. $150 billion investment already made by the government, between now and 2030. And that's just the public money. That doesn't include all the private money that, where they're making their own choices and stuff. Mr. Putin was at a university and basically telling all these university students in Moscow last year, this is the way forward. This is what we're going to do. He does scare me a little. Anybody would when he says the industry leader will rule the world. So I would actually like to see all of us in such a position where we can kind of keep that on a level playing field for the entire world. Sorry, fake AI. Just had to throw funny in. Don't be offended if you are. It's just a joke, not a political statement. So I once put that in a slide and actually had someone stand up and storm out. So you'd think I would have learned my lesson by now. So let's talk about the secret sauce for deep learning. Why is it special? Why does this matter to us? And why is it driving digital transformation? Well, you could think of deep neural networks as a way to precisely approximate any function or any continuous function. And so if you're thinking about that, that means that just about any process imaginable involves a function. You know, tying your shoes is a function of sorts. Anything where you're going to have something that an input affects an output. Now, I'm looking at a lot of you, and you're looking like this, which is why I put this slide up. It doesn't sound very sexy, but I would argue that this is a really huge thing. It means that we're really talking about a set of tools that can be applied universally. And I'll move back here. And that means that if you want to solve complex problems, this is the first widely used toolkit we've ever had in technology that can be applied across a wide spectrum of industries and problems they have, since you can try to approximate what any of those functions would be. So I think that's pretty super cool. Homer's got it. But you know, if you're skeptical, which I would be, because I'm saying all these hyped up things, I want to acknowledge that deep learning about a year ago was right at the top of the hype cycle. I haven't seen an updated graphic yet, so I don't know where it would be considered at this point. But you know, we're at that point where it's like, it's just come out. We can solve the world. And I sort of just said that. But we're at a point on that curve where you have to have realistic expectations. So I would say ignore the hype and focus on the practical. Focus on what you can do with it right now. What kind of problems can it be solved? The tool set will probably get better over time, but don't waste your time getting outside the realm of reality at this point. So let's talk for just a moment about how neural networks work. And I don't know, in any given audience, some people know it inside and out. They're like, I already know that. And some people don't. They're just getting into it at this point. So obviously it's time for some serious math. Maybe not. Not everybody wants to do serious math on a Friday afternoon, so I'm just joking. So what we really want to go for is kind of an intuition for how this is working. And I just wanted to kind of get you in that right mindset, figure out, okay, what does that mean? How do I walk away with intuition? And that is, the purpose of training is to be able to make generalized predictions from known correct results. Okay, this is supervised learning. So that means that we have a reality that we're modeling. We already know what that reality is, and we want to be able to take that and then extend it with unknowns later on. It takes a lot of known correct results. Those of you who have been working in this space know it takes maybe hundreds of thousands or millions of records to get a model trained at times. But the pretty cool thing about it is that once you've trained it, then new things that your model has never seen, if it's still addressing the same problem, you can take unknowns and put them through and get the right answers with very high degrees of efficiency. And so you're really allowing it to learn from experience, and you're really getting the neural network is really able to abstract the different concepts that affect that problem and codify them so that you can use them. And you have relationships that are captured in the model. This is what a toy model looks like, very much a toy. Where you have those different neurons that are passing across the layers. No one uses sigmoid anymore in real life, but it's often a training tool. And then the inside of each neuron does some simple math. And I'm not going to go any farther into it than that, other than to say that as you looked at those different arrows, the weights of each one of those changes as you train. And so your neural network, you can start with the same architecture, but if you apply it to different problems, or even the same problem with slightly different data, you can come up with a unique set of weights which represents reality for you. So I'll skip through the details here, but that's what the end of it looks like, is you have a lot of different trains. So that is what is able to do. It is essentially capturing the world through a nested series of models that all have relationships to each other. And so right now, these are some of the popular architectures that are out. We've talked about feed-forward, backpropagation, that was the one we just showed. Convolutional is focusing on machine vision. It's used a lot in robotics. Recurrent is capturing time-based most often, including speech recognition, that kind of thing. And then generative adversarial networks are a way of creating data. You actually set up a couple of neural networks where one is generating possibilities and the other one is discriminating what is real and what's not. And when you've seen music created that is created by AI, or imagery that's created where they do pictures, maybe lifelike, maybe something very abstract, that's done through these scans. And this is just a demonstration of the convolutions that a convolutional neural network, machine vision, is doing, where it's basically taking something it sees and simplifying the data without losing the essence of what it's captured there. So data strategy, you got a lot of data to tackle. It's the eye. It never goes away. It never stops. Lots of data, lots of computation. So the point I'm trying to make is that an AI strategy requires, as a prerequisite, an executed and evolving data strategy. If you don't have that data strategy in place ahead of time, this is what's going to happen. And that happens a lot. Doing the stuff that I do, I talk to lots of different people at different organizations, and this is the most common thing where people have dived into it quickly and they've made mistakes. So get your data strategy in order. It's not as sexy, it's not as fun for a lot of people, but do it before you dive into the AI space. Investing in deep learning is really crucial. You really have to think of yourselves, if you want digital transformation to work for your organization, then you really need to have champions within your organization that say, okay, we have these great new tools. So we're going to work with a lot of different people in the organization. Some of those are the data scientists. Some of those are technical, a lot of business people, and specific product and service focus. And focus those people together very much in a startup mentality where you're kind of going through and saying, how does this change what our product or service should be? How do we apply data in a way to extract it so that we can create these new innovations that we couldn't do yesterday? So this is the model that has worked well for me. It's almost like having a team, but that team then, as they're going through this process, has to spread this culturally through the rest of the organization. And most of the major organizations in the world that have been doing this type of stuff well have started with small teams that then grow as they have successes and move their way out. These are questions that you would want to start with in terms of, are we prepared to fail? You have to fail a lot to get this right. Very startup mentality. Pivoting is the word in the startup world. You have to be able to pivot well, understand what the problem you're trying to solve is, and not only from a technical perspective, but does it satisfy your customer? As you're applying digital transformation to the operations of the business, are you going to be able to change the reality your customer is experiencing? Do you have the right data that you need to transfer? Where is it, and how do you get it transformed into the formats that you're going to need to train your models and then support your models in production? So it goes back to what I showed you earlier on. It goes back to, what is my customer asking me to do, and how can we apply these to actually serve that customer better? So analyze the problem statement, figure out if you can solve it with less expensive tools than diving into deep learning techniques, because it's expensive. And a lot of times it's simply the wrong solution. Why would you pick a more complex way of solving a business problem if it doesn't work? So it's expensive to scale. It's one thing for us to go and grab a small AWS instance and try something at home, but once you go to scale, it's very quickly, you can move your budget for compute can move into tens of thousands, hundreds of thousands, millions of dollars on an annual basis. There was a guy that came to the deep learning meetup about a year ago, and we were talking about his company had a startup, and he started running a model, and he kind of left it and stopped thinking about it, and he didn't put any parameters around it. And he came back once it finally got to the error rate that he was looking for, and he had accidentally spent $10,000. That they were a startup. They had 4 people. They didn't have $10,000 around. So he said that was a big. It almost cost him the company. They got through it, but this stuff goes from not expensive at all to we're now solving big customer problems. We got a lot of data coming in, and it can move right up there. It really needs a strategic investment from your leadership team. This is something I found out the hard way. If your CEO and the other executives in your organization don't understand that you are trying new things here and that you're going to have failures as a part of that process, and that you're going to have to find your way forward. And it's a little bit different from every other company. They're going to be frustrated after they're spending resources and they're not getting the results yet that they want. So you want to recruit the best people you can find, and you also want to train the best people that you already have. It's definitely hard to find affordable data scientists that are experienced in deep learning. You want to have a learning culture. You're constantly having to learn new things in this field. It changes day to day. And you need to recognize it's not just data scientists out there doing that. You have a number of people. You have data scientists, data engineers getting the data where it needs to be for training, software engineers, because you got to actually deliver that data into a useful context, the inferences that are coming from that, and domain experts. What does the customer need us to do? How do we know what to do? So also recognize that just because you're a data scientist doesn't mean you're a deep learning expert. It's a whole new skill set. It's great to be a data scientist moving into it, but you're going to have to invest in that, and we'd had to do that. You need to have a process. It's really not so different from other processes from a data science perspective. Understand the business problem, understand if it's measurable and how you're going to validate the value on it, understand everything about your data, format, understanding feasibility, and the bottom one surprises people sometimes, target hardware. We're starting to see it change, but for a while, it was really hard to have things out on the edge that were capable of supporting inferencing. Not everything had a chip in it, a GPU or a TPU or an ASIC that was able to support this. So that can stop you dead, even if you have an awesome model there. You need to understand what the training, the evaluation process is after you've made your initial selection, and then focus on the software that it has to fit in the deployment cycle, the systems it has to work with, and how are you going to keep this process going? We've been doing software engineering for years, doing continuous deployment. We kind of know how to do that, but we're still learning this in this space. How do we actually get new models out as we're training them over time? So we talked a little bit about the cloud infrastructure that's available these days. They're always competing. There's good deals to be had. And on a day-to-day basis, you can see price drops and competitive changes. You can buy your own hardware. This is a supercomputer from NVIDIA. It's currently the top supercomputer, but that also changes very rapidly. And then, pick your framework of choice. We got lots of amazing open source alternatives. Go pick one. They're all very good. And so pick what you're most comfortable with, dive into it, and really get your hands dirty on that, regardless of which one you pick. You're hearing the most talk these days about PyTorch and TensorFlow, but that's just what's in the media. It could be different tomorrow. These are some other tools that I tend to use. Docker is kind of how we deploy software these days, how that's kind of becoming the standard. Kubernetes from Google is how you orchestrate all that software. And you may not have heard of Pachyderm, but it's sort of it's a great way of moving data around through workflows to support your processes. So these are amazing open source tools that are democratizing this process and giving you the ability to do it. So what I would say is, the bottom line is think about it as something that needs to be practical, productive, and accessible to everyone. Don't let it intimidate you. Recognize that everything you need is available online. And really the only thing you're having to pay for is compute. You do have to pay for compute, but there's tons of data out there, and there is tons of framework and tools to get it done. If you need to ramp up on the math, if you're coming from a field that you didn't have the PhD in mathematics, tools are out there. Honestly, Khan Academy is great for learning a lot of the things that you need to get ramped up to. So just go do it, and that's it. This is my podcast. I invite you to listen in, and that's it. Thank you very much.